All right, guys, so now that we have a basic idea of what polar coordinates are, I want to look at how we can convert from polar coordinates back to rectangular coordinates. So let's say we have some point, r and theta. I'm just going to draw it in quadrant one just for simplicity, but it could be in any of our four quadrants. And I want to think about how we can take this point and convert it into rectangular coordinates. So polar coordinates, we know, are based off of a radius and an angle theta. So what we're trying to figure out then is what is our x value and our y value that will get us back to that same point. Well, you might notice here that we have just drawn a right triangle. So if we're trying to figure out x and y, basically all we need to do is use our basic trig ratios. So let's say we want to think about x, okay? Based on our angle theta, x would be our adjacent side, and we already know our hypotenuse of r. So that would be looking at our cosine function. So we could say cosine of theta is equal to x over r, or if we rearrange this, x is equal to r cosine of theta. Right? And similarly, if we were looking for our y, that's our opposite side in this case. So using our opposite and our hypotenuse, that would be our sine function. So sine here would be equal to y over r, or rearranging it, y is equal to r sine of theta. Okay, and that's exactly what I have written right here. So if we're given a point in polar coordinates r and theta, and we want to convert them into rectangular coordinates, then we just use these two formulas. X is equal to r cosine of theta, and y is equal to r sine of theta. Now you might notice that really these aren't significantly different than anything we already know. We've been saying for months now that if we have our unit circle, right, you have a unit circle and you have a point x and y on that unit circle, then we know that x is equal to cosine of theta and y is equal to sine of theta. Okay, well, the reason why is because in the case of the unit circle, our radius is 1. So r cosine of theta is just cosine of theta, and r sine of theta is sine of theta. But in a more general case where our radius isn't 1, then we still need to include that r on there. Okay, so this is basically just an extension of what we already know from our unit circle. It's just a little bit more generalized. Okay, so let's go ahead and let's take a look at an example here, converting from our polar coordinates to our rectangular coordinates. Okay, so we want to find our rectangular coordinates for the point 4, 2 pi over 3, so that's our r and our theta, and we're just going to use the two formulas from above. So we know that x is equal to r cosine of theta, and we know that y is equal to r sine of theta. So we're simply going to plug in our r and our theta and then simplify. Okay, so let's start with x. So in this case, x is going to be equal to 4 times the cosine of 2 pi over 3. 2 pi over 3 is one of our unit circle angles, so we can evaluate cosine of 2 pi over 3. That would just be equal to a negative 1/2. And then 4 times negative 1/2 is just negative 2. All right, so as long as this is on your unit circle, I want to see the exact value. If it's not on the unit circle, then you can plug it into the calculator and get a decimal approximation for it. But if it's a unit circle angle, I want an exact value. Okay. All right, so then we can do the same thing to find y. So y is r sine of theta. So in this case, it would just be 4 sine of 2 pi over 3. Sine of 2 pi over 3 is square root of 3 over 2. And 4 times the square root of 3 over 2 is just 2 root 3. Okay. All right, so then just writing this as an ordered pair, our answer would be negative 2, 2 root 3. Okay. Now, one thing you can do just kind of as a rough check for yourself to make sure that this makes sense, just think about plotting this point real quick. So our original point was 4 and 2 pi over 3, right? So 2 pi over 3 is in quadrant 2. That would be right there. Radius of 2. So just go out 1, 2, and we'd have our point right here in quadrant 2. Okay, so just kind of making sure that adds up here. Our new point in x and y coordinates, oops, I have an extra rogue parenthesis in there. All right, so x is negative, y is positive. So x is negative, y is positive, which would also bring us to quadrant 2. Okay, so we can at least do that rough check to make sure that our point came out in the correct quadrant. All right, so let's take a look at going the other direction now. So converting from rectangular back into polar. So I'm again just going to show you where these formulas come from. So let's think about, we have some point, x and y. I'm just going to again draw in quadrant 1 for simplicity. So we know that the horizontal and vertical distance up to this point are x and y. So if we want to find our polar coordinates, we need to know an r value and a theta value. Okay. Well, in this case, based on the information we know, if we know x and we know y, and we're trying to find r, well, that's just Pythagorean theorem. We know x squared plus y squared is equal to r squared. So that is going to help us find our radius value. And of course, if we were to solve for our r, we would find that in general, r is equal to either plus or minus the square root of x squared plus y squared. Okay. Notice we do have the plus and minus here because as we've seen in polar coordinates, the radius can either be positive or negative. So we're going to get multiple answers in polar coordinates for every point plotted in rectangular coordinates. Okay. All right, so then if we were trying to solve for our angle theta here, again, remember we know x and we know y, so that's our opposite and our adjacent side, so we can use tangent in order to get that. So tangent of theta would be equal to y over x. Okay. All right, so let's go ahead and let's take a look at example 4 here, and let's try to find our polar coordinates for this rectangular coordinate. So in this case, 2, negative 2 is our rectangular coordinates. That's our x and our y, and we're trying to find our corresponding polar coordinates. Okay. All right, now whenever I'm doing this, I like to start by just making a rough sketch. So 2, negative 2 is just telling me that I have my point down here in quadrant 4. The reason why I'm making sure to do this is because in a few minutes, we're going to have to make a choice between different angles, and we want to make sure that we choose the angle that falls within the right quadrant. So it's important to always make that little sketch. Okay, so let's start by finding our radius. So we know that x squared plus y squared is equal to r squared. Okay, just basic Pythagorean theorem. So if we plug in our x and y, we'll have 2 squared plus negative 2 squared is equal to r squared, which would mean r is equal to plus or minus the square root of 8, or if we simplify that, r is equal to plus or minus 2 square root of 2. Okay. All right. So 2 different potential radius values, positive 2 root 2 and negative 2 root 2. All right, then we can use our tangent in order to find our theta. Okay, just using the fact that tangent of theta is equal to y over x, okay? And we already know that. That's the same as what we've been using off of our unit circle since we learned that, so that's nothing new right there. So tangent of theta in this case would be equal to negative 2 over 2, or that would just reduce down to tangent of theta is equal to negative 1. Okay, well, we know where that happens if we think about our unit circle. tangent is equal to -1 in two places, either in quadrant 2 at 3 pi over 4, or in quadrant 4 at 7 pi over 4. Sorry guys, my phone's ringing. It should stop in a minute. Okay, so now we have to think about how to put these together. Okay, so we know that we want our final answer to be over here in quadrant 4. Right? Now the angle that's in quadrant 4 is of course the 7 pi over 4. So if we want to use the angle of 7 pi over 4, because that's the actual quadrant that our point is in, we're going to pair it with the positive radius, right? So one potential answer would be positive 2 root 2 7 pi over 4. And again, the reason I'm putting 7 pi over 4 with the positive radius is because our point that we plotted is in quadrant 4, okay? So we want to keep it in quadrant 4. All right, well then, if we think about the angle of 3 pi over 4, 3 pi over 4 is over here in quadrant 2, directly across from our point. So if we're over here in the angle of 3 pi over 2, we want to pair that with a negative radius, because the negative radius is going to flip it across the origin and bring it back to where we want in quadrant 4. So another possible answer would be negative 2 root 2 and 3 pi over 4. Okay, now just to kind of show you, there are several other ways that we could write this point, okay? So for example, I could also say, well, another way to get to that point would be to use a negative angle. So we could do something like 2 root 2 and negative pi over 4, okay? And there's a lot of other ways that we can get back to that same point. Now, you obviously don't need to get every possibility, but I'd like if you found at least two different ways to write these points when we're converting from rectangular into polar coordinates. And as you go through and you do your homeworks and you do your labs, you might find that the answers that I have in the solutions aren't exactly the same as yours, but as long as they fall in the same location, then you're good to go, okay? Because there are lots of different ways to write a point in polar coordinates. All right, guys, I'm going to go ahead and end this video here. And in the next video, we're going to take one more look at these polar coordinates, and we're going to look at converting entire equations between polar and rectangular form.